do things for a reason. So we are going to, oops, there we go. Going to put this into some context of physics, the reason that we're doing this. If you were working on your analysis questions, you may have already realized what our real purpose in this was. Remind me on my little, my pretend graph here. What do I have on the x-axis? Time. You all put you all put time on the x-axis in seconds because time was the what variable for you? That was the independent variable, right? You had the person that was standing there with the stopwatch going, go, 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 right? That was the thing that you picked or that you were told to pick, perhaps, okay? And then what did you have on your y-axis? Distance, because that was your dependent variable, yeah. And you measured that either in meters or centimeters. Either way is okay as long as you're consistent. It doesn't matter. And then the thing that you were asked to do is to calculate the slope, the rise over run, right? The rise over run, and you know this, but I'm just reiterating this to make sure that it's very clear. The slope is the change in y over the change in x. The change in y being the distance over the change in x being the time. And distance over time is a measure of speed or velocity. As physicists, we're going to call it velocity. We'll get into the ins and outs of why it's velocity and what the difference is between velocity and speed another day. Not right now, though, because we've got other things to do. I want to make sure that we get some problem solving done. So this would be a big thing to write down, to put a circle around, to put a box around, whatever that is. I will get you an equation sheet. I don't know, probably not today, but one of these days, that's the first equation on it. So there you go. Yay, welcome to equation land. It's here, okay? Velocity is equal to distance over time. It's true. It's actually displacement. We're not going to get into the idiosyncrasies there, but that is where we are. Is that okay with everybody? Okay. So now, in addition to finishing up that lab, I also do want you to do just a couple of problems for homework. I mentioned that, and they are some calculation problems. So we're going to go through the process of learning how to do physics calculations. There are some things that I really don't care about, like I've mentioned, like sig figs, right? But there are some things that I really do care about, like problem-solving process in physics. I am pretty picky about this. I know that I have some friends in here for whom the process is like so obvious, like boom, I can tell you that the answer is 7 without really looking at it. There will be some things that we do throughout the year, though, where that's not super obvious. And so what I want you to get used to doing is manipulating the data and manipulating equations. And so I want you to write things down, the whole thing from the beginning, okay? So we're going to look at a couple of problems today before the end of the class. Besides loving to teach physics, I feel that one of my callings in education is to make sure that the next generation of Americans know who the Muppets are. I love the Muppets very, very much. And I think it's an important thing to be carried on into the future. So you'll see a number of problems throughout the year about my favorite Muppets. Kermit is one that most people know, which is why I pick on him first. Kermit the Frog, right? He's so cute and so lovable and whatever. Anyway, so we're going to talk a problem about Kermit. We're going to write this out. I'm going to remind you of the equation, the one that we just wrote down so that we know it. The equation that we said was velocity is equal to distance or displacement. I'm going to write it as displacement. Again, we'll talk about what that means in a second. Over time. Okay. And then I'm going to tell you the way, how do we solve these problems? How do you do a problem? I'm just trying to see if I get the right variables here. What do they like? They like X and B and A. So this would be written as V equals delta X over T. So the way that one solves a problem in physics, how do you do it? Guess, right? What? The answer's 7, I think. I don't know. I'm putting out a guess. Really, that's not what it is, right? Guess means that you're going to start with your givens. Okay? I know that some of you are like, man, I hate writing out my givens, but it's going to pay off, I promise. So for a few days, it's going to take a little while to have to put up with that, but it will pay off in the future. U is for your unknowns. E is for your equation. That first S is to solve, and finally to find the solution. Okay? Process over result. Process over result. I think I mentioned to you on the very first day that a lot of, or maybe not first day, but at some point in the last week, that there is very little actual calculation on the AP Physics exam. I'm going to have you do some calculation because I think it's important, but it's all about process. It's all about figuring out this piece. So I need to make sure that you know how to do that and that you feel confident in that way. Okay, so we're going to solve this problem. It's pretty easy, pretty little, right? How far does Kermit walk if he maintains a speed of 1.5 meters per second for 2 minutes? Let's start at the beginning, right? Let's start by writing down our givens. Here they come. So we're going to actually literally write out givens. Tell me if you know a given. You see anything up there you know? Velocity? The identity of the object is not one of the givens that we need to know to solve the problem. But good point, yes. What's another piece of information that we might need to know to solve the problem? The 2 minutes. And what is 2 minutes? It is time. The little red flag goes up in your brain. Beep, 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 beep. This is in minutes. This is in seconds. So we'll need to do some conversion here, right? This is one of those conversions you might be able to do in your head. How many seconds are in 2 minutes? So there's 60 seconds in 1 minute. So in 2 minutes, we'd have 120 seconds. Fantastic. All right. Those are the two givens we know. What's our unknown? What does it say? How far does he go? Yep. So we're going to have distance, delta x. All right. What equation am I going to use? I only have one. Probably that's the one, right? The reason we do this, though, is so that we can find the equation if we have lots of them to choose from. So v equals delta x over t. Now we're going to solve. This is our first opportunity to do algebra together, you guys. This is so nice. It's a touching moment. We haven't done algebra together yet. I want to get delta x by itself. How do I do that? Multiply both sides by t, right? Multiply both sides by t. T's go away. I can say that delta x is equal to t times v. Okay. Plug that in. So I've got 120 seconds times 1.5 meters per second. That equals something like what, 180 meters? Fair enough? Okay. Pretty straightforward problem. The reason I gave you a straightforward one to start with was because then we can go through the steps. You can see what's going on without getting too wrapped up in the mathematics that's happening there. Okay? Givens, unknown, equation, solve it, and then you've got your solution. When you have problems that need to be solved like this, generally, not every time, but generally on those problems, they're worth about 4 points. Okay? One for the givens and unknown, one for the equation, one for the work, and one for the answer with units. So if you just wrote, if you're one of those people that do it in your head, you get 180, you just write 180 down, how many points do you get? 1. 0. No units, right? If you just write 180, 0 points. That's really sad. I love that you can do things in your head. That's wonderful, but again, not a lot of calculation happening on the actual exam, so I really want to see this process. This is what I'm looking for, okay? If you write just 180 meters, you get 1 point, okay? Write those givens. Let's say that you're working on a problem, you have no idea what you're doing, okay? This is true no matter if it's a calculation problem or you're looking at this thing and you're like, I don't even know where to start. If you can start to write down ideas, you will get credit for that. That's why I want you to get in this habit. Is that making sense? Seem fair? Okay, let's do one more. Because we've got a couple minutes. We ready for something a little bit more challenging? Yeah, bring it on. All right, here we go. In college softball, the distance from the pitcher's mound to the batter is 43 feet. What? That's disgusting. I'm sorry that these units are terrible. If the ball leaves the bat at 100 miles per hour, what? How much time elapses between the hit and the ball reaching the pitcher. Let's go ahead and find the answer. I don't know, in what, seconds? Can we do that? Let's do that. In seconds. There's some conversion that needs to happen here, huh? So how much time elapses? We'll say in seconds. Do we know conversions here? How many feet are in a mile? Anybody? Look at you guys being indoctrinated. I love it. 5,280 feet in 1 mile. If you don't know that, you don't have to have that memorized for me. Okay? Just, I'm giving it to you now. Boom, there it is. Okay? One of those little junior high indoctrination things, probably, right? And we can know hours to seconds. We can just write that down too. How many seconds are in an hour?
Are you sure that's miles per hour, not meters per hour?
I'm sure it's miles per hour. Thanks for asking. Good question. I think when it's written like this, it's implied that it's miles per hour. Yes. Fair question, though.
Are you sure it's not times speed?
I mean, you don't have to fight with me. If you don't want to do the problem, I'm not going to force you to. Okay? All right. How many seconds? How many seconds are in an hour? 3,600, right? All right, go for it. Do the problem. Absolutely talk to each other. Absolutely have a conversation. Help each other out. Oops. Now, can I just interrupt for a second here to let you know, for those of you for whom algebra in your head is easy, I do not need to see every single step of algebra to rearrange an equation. That is absolutely fine. I generally, when I'm doing a problem, write out every single step for my friends for whom algebra in their head is not easy. But if you know that v equals delta x over t automatically goes to t equals delta x over v, and you can just see that, then just write that and that. That is absolutely fine. You don't need to show me all those steps. If it doesn't make sense, write it out by all means. Please and thank you. Did you guys get a velocity of like 146-ish? Okay, good.
Is this second? Okay. Good question.
We doing okay? No? I'll help you out. If you want me to finish, I just have to finish calculating. I can help you. Otherwise, have a great weekend. Do your homework this weekend. I'll see you soon.